In this lesson, we're going to look at place value or positional value numeration systems. The most common type of numeration system that is used today is called the place value system, also known as the positional value system, where the value of the symbol depends on its position and the representation of the number. So if you take any number, let's say we have a 4-digit number and our decimal place is to the right. In that first place there, we have the ones position. In the second, we have our tens. In the third, we have our hundreds. And in the fourth place, we have our thousands. So we can represent this system using what's called the decimal number system. It's the most common positional value system, and it's what we call a base 10 number system. Okay, the base 10 number system was actually developed from counting on fingers. The Hindu-Arabic numerals and the positional value system of numeration revolutionized mathematics by making the operations, which are addition, subtraction, multiplication, division, easier to learn and more practical to use. So instead of using an abacus or a counting board, merchants computed with a Hindu-Arabic system. In the Hindu-Arabic system, we know that the symbols 0 through 9 are called digits, and that comes from the Latin word for fingers. The positional values in the Hindu-Arabic system are, starting in the ones place, a 1, and in the tens place, we have a 10, and then it's hundredths, 10 to the second, 10 times 10, thousandths, 10 to the third, or 10 times 10 times 10, 10,000ths, 100,000ths, and so on, depending on how large the number is. What we're going to do is we're going to practice writing numerals in expanded form using this place value rule. So as you can see here, we multiply the digit n places from the right by 10 to the n minus 1. And n is just the number of places that the numeral takes up. So for example, in the number 1234, 1,234, if I wanted to write that in standard form, there's 4 places here, so I know n would equal 4. So that means that I'm going to then take this 1 and multiply it by 10 to the 4 minus 1. And then I'm going to take the second place, which is 2, and multiply it by 10 to the 4 minus 2, and so on. 10 to the 4 minus 1 times 3, or sorry, it should be 3. And then 4 times 10 to the 4 minus 4. So we know that this is really just 1 times 10 to the third plus 2 times 10 squared plus 3 times 10 to the first plus 4 times 10 to the 0. And we know that, let me make this a little smaller. We know that 10 to the third is just 1,000. So it's just 1 times 1,000 plus 2 times 100 plus 3 times 10 plus 4 times anything to the 0 power is 1. So 10 to the 0 is 1. And then this is just 1,234. And this is written in expanded form. Let's talk about the Babylonian numerals again. It's the oldest known numeration system. We discussed this back in 4.1, and it resembled a place value system. Their system resembled a place value system with a base of 60, and we call that a sexagesimal system. Okay, this is not a true place value because it lacked a symbol for 0, which, remember, caused some problems, right? So there were other civilizations that did take into account 0. So we had these symbols where this upside down triangle looks like a 1, and then this arrow looking symbol represented a 10. So these are the Babylonian numerals up top, and then the numbers we use now, the Hindu Arabic numerals, are in the bottom of that chart. Okay. The positional values in the Babylonian system are not like the ones we use in our decimal system, right? Where we had 1 and then we had 10 to the first, 10 to the second, 10 to the third. Since it's base 60, we have 1 and then 60 to the first, 60 to the second, and 60 to the third. In Babylonian numeral, we leave a gap between the characters to distinguish between various place values. And from right to left, the sum of the first group of numerals is multiplied by 1. So we would multiply these by 1 here. And the sum of the second group is multiplied by 60. And then if there was a third group, we would multiply by 60 to the second, and so on. So if we were to write these Babylonian numerals as our Hindu Arabic numerals, the ones that we're familiar with, again, we would have this first group here, this number. So I have 2 arrows, which represents 10 times 2. So that's 20 plus 2. So that's 22 times 1. And then there's a space. So that means we're going to multiply this numeral here by 60. So we've got 23 times 60. And then we would just add those together. So 23 times 60 gives us 1380, and 22 times 1, of course, is 22. And if we add those together, we get 1,402. The Babylonians did have a symbol for subtraction, and it was a combination of their 2 symbols. So this time it's the upside down triangle, if you will, and then the arrow pointing to the right. So when you see that symbol, it represents subtraction. So here, for instance, we have 10 minus 2. We're 8. So that would be the number 8. Okay. So here we've got our upside down triangles. So those each represent 1. Here we have a 10 and a 1. And then here we have 20 and then minus 2. So remember, starting from right to left, so right to left, we're going to multiply the first group by 1. So this number here is 20 minus 2, and then we're going to multiply that by 1. And then here we've got 10 plus 1, which is 11, and we're going to multiply that by 60. And then in this first group here, we have 20 and times 60 squared. Okay, so it's 60 to the 0 power, which is 1, 60 to the first, 60 to the second, as you go from right to left. And here we have 7,200 plus 660. 20 minus 2 is 18 times 1, which is 18. And if I add those together, I get 7878, or 7,878. Now, what if I want to take a number that's Hindu Arabic and express it as a Babylonian numeral? I kind of have to go backwards now. So if you think here, to go from Babylonian to Hindu Arabic, we multiplied. Now we're going to go backwards, so we're going to divide whenever we want to write Hindu Arabic as Babylonian. So what we're going to do is we're going to divide by the largest positional value that's less than or equal to that number. Okay, so what I mean by that, remember that the Babylonians had a base 60, and that just meant that it was 60 squared, 60 to the first, 0, okay? And what we're going to do is figure out which of these numbers here will divide into 2519, okay, the highest of them. So if I take if I just go to a calculator, so I'm just going to use Desmos, okay, I'll first start 2519 divided by 60. Okay, so we know it goes in 41.983 repeating times. But I want to see what the largest value would be that can go into 2519. So remember, after 60 is 60 squared. So now I want to do 2519 divided by 60 to the second power. Okay, and it can't go into it. And I know that because the answer I just got was 0.69972, which is less than 1. So that means that 2519, the largest positional value that I could multiply, that I could divide into 2519 without, with possibly having a remainder, would be 60, okay? Because 60 squared is too high. So I'm going to start with 60, and I'm going to divide 60 into 2519, okay? And as we know from looking at Desmos, I know it goes in 41 times. So automatically I know this is going to be a 41. When I multiply 41 times 60, 41 times 60 gives me 2460. Okay, so I know that I didn't go over because I can subtract and I still have a remainder. So the remainder now, 9 minus 0 is 9, 11 minus 6 is 5, so that's 41, remainder 59. Okay, so this just means we can get 41 groups of 60 rather, and this would be the units remaining, 59. Okay, now I'm going to look at my numbers again and see if I can divide any of them into the remainder. And since I can't, 60 can't go into 59. Since I can't, I'm going to then stop right there. Okay, so what that means is since I divided by 60, it's going to be this number times 60, right? There's 41 groups of 60. And then there's 59 units remaining. So unit means 1. I'm just going to multiply 59 times 1. So I have 41 times 60. So remember that arrows represent 10. I would need 4 of them and a 1. And then I would leave a space. And then 59. So the only way to get 59 is to do 60. So I would need 6 of those. And then we want to subtract 1. So remember, subtraction's the upside down triangle and the little arrow above it pointing to the right. That means subtract and then 1. So that represents 60 minus 1, which is 59. And by the way, that should be a 1, not a 0. Okay, there's some problems here that you can try as well. Let's talk about the Mayan numerals next. So this is just another place value system similar to the Babylonians. And it was developed by the Mayans, which lived on the Yucatan Peninsula in Mexico. And it was based on the religious and agricultural calendar. So it's a very sophisticated numeral system. They write their numerals vertically with the units position on the bottom, as you can see here. So that would be the units or the ones. And then the numeral in the second row is multiplied by 20. And then the numeral in the third row is multiplied by 360, which is actually 18 times 20. And then it would be 18 times 20 to the second, 18 times 20 to the third, and so on. Okay, the digits are 0 through 19. And they are formed by a simple grouping of dots and lines as shown in the table. Okay, so for example, if I was to take that Mayan numeral there and write that as a Hindu Arabic numeral, we just multiply the bottom number, That's in the ones, so we're going to multiply by 1. And if I look at the table here, we've got our 3 horizontal bars and a dot on top, and that would be the number 16. So that's just going to be 16 times 1. And then we've got the 3 dots, that's just 3. And then I'm going to multiply that by 20. And then I've got on the top, I have an 11. And then I'm going to multiply it by 18 by 20. So I'm just following this right here. Multiply the bottom row by 1 because that's the units. And then the second row is by 20. The third would be 18 times 20. And then 18 times 20 squared, 18 times 20 to the third, and so on. So when I multiply 11 times 18 times 20, I get 3960. 3 times 20 is 60, and 16 times 1, of course, is 16. And when I add it, you get 4,036. Okay, let's try one more. This time we have a 4-digit number. So here I have 4 dots. That just represents 4, and I'm going to multiply that by 1. And then I've got this like saucer-looking thing. It's like a UFO. That's the number 0. So the Mayans actually had a symbol for 0. Remember, the Babylonians did not, so that made things very confusing. Since that's the second row, we're going to multiply it by 20. And then in the third row, I've got 8. And I'm going to multiply that by 18 times 20. And then in the top row, I have 2. And I'm going to multiply that by 18 times 20 squared. So when you multiply this out, you get 14,400, 2880, 0, and 4. And we're just going to add vertically. And if you add those together, you get 17,284. Okay. So now let's go backwards. We have our Hindu Arabic numerals. We want to write them as Mayans. And we're going to use a method very similar to the one when we were converting to Babylonian. So remember, we want to divide by the largest positional value less than or equal to that number. So remember, we've got starting at the bottom, right? If you think of it as 1, and then 20, 18 times 20, 18 times 20 squared, 18 times 20 to the third, and so on. So I'm going to figure out which of those will divide into 4,025 without going over, okay? And I can certainly divide 20 into 4,025, but I can also divide 18 times 20, which is just 360. I can divide 4,025 by 360. If I try to divide 4,025 by 18 by 20 squared, as you'll see, it'll go over, right? So if I was to do 4025 divided by 18 by 20, okay, it's perfect. It can go in 11 times. But if you do 4025 divided by 18 times 20 squared, you'll see you'll get a number that is less than 1, so you went too far. So 18 times 20, or 360, is the magic number. So I'm going to divide. I'm going to start with 360. And I'm going to divide 4025 by 360. And as you already saw, it went in 11 times. So now I want to do 11 times 360, which is 3960. So I'm going to subtract that, and you would get 65. So that's my remainder. That means you've got 11 groups of 360 and then 65 units remaining. Okay, so this represents groups of 360, and then this is the number of units remaining. Okay, so now I'm not finished because if you look at your list, I can divide 65 by 20. So now I'm going to do 20 into 65. And we know 20 goes into 65 3 times. 3 times 20 gives us 60. So my remainder is 5. So that means you've got 3 groups of 20 with 5 units remaining. Okay, and now I can stop because the only other number we would be left with is 1. So now I'm just going to write this out. This would just be 11 times 360 plus 3 times 20. And then there's 5 units remaining. Unit means 1. We're just going to multiply our remainder 5 by 1. So it's basically the numbers we're using would be this number, and this number. Okay, as you can see, 11, 3, and 5. And if I multiply that out, you would get 4,025, but we need to write this as a Hindu Arabic numeral. So we know 11, if we look at our chart here, I'm going to be using the symbols for 11, and then the symbol for 3, and then the symbol for 5. Okay, and we're going to write it vertically. So if you do that, it's going to look like this. So here's an 11, and then 3, and then 5. So that's how you would write the Hindu Arabic numeral 4025 as a Mayan numeral. Okay, one more. So if we write 21,846 as a Mayan numeral, again, I want to divide this number by these numbers. What's the highest that I can divide into it? So let's see. Okay, so I'm going to take 21,846. I know 20 will go into it. I know 18 times 20 will go into it. How about 18 times 20 squared? Okay, so that looks like it's going to be the highest. If you try 20 to the third, it'll be too high. So 21,846 divided by 18 times 20 to the third. Yep, we get a number less than 1, so it's too high. So I'm going to take 21,846 and divide it by 18 times 20 squared. 18 times 20 squared is 7,200. So we're just dividing 21,846 by 7,200, which remember is 18 times 20 squared. Okay, so that's the highest that's going to go. And when you divide 7,200 into 21,846, we saw it went in 3 times. 3 times 7,200 gives me 21,600. And when you subtract, you get a remainder of 246. So that means you've got 3 groups of 18 times 20 squared with 246 units remaining. So now I'm going to look at my other numbers. Since I divided by 7,200, right, I want to look at these numbers. Can 360 and 20 go into 246? So 360 is too high, right? So that just means then that we're going to put a 0 for that place value right there, because 360 cannot go into 246, but 20 can. So now I'm going to do 20 into 246. So 20 goes into 246 12 times, and 12 times 20 gives me 240. So we get 6 for our remainder, and we're done, right? Because underneath 20 is 1. So we're finished. So remember now, you've got your 3, and then underneath that, you skipped from 7,200 you skipped over the 360 because remember 360 can't go into 246. So I need a symbol for 0, which kind of looked like kind of like a UFO in a way, or a hamburger if you're hungry. And then I would have 12, so that's the equal sign with the two dots above it. And then my units, which would be 6, and that's the bar with the dot above it. So that's how you would express that Hindu Arabic numeral as a Mayan numeral. And that's it. If anybody has any questions, please feel free to reach out to me. Hope you all enjoy the rest of your day.